Namaste. In this session, we'll discuss about the topic electromagnetic induction. In that, expected questions. Okay, expected questions. Okay, ಇಲ್ಲಿ electromagnetic induction ಅಲ್ಲಿ 1 mark question ಇಂದ 2 ಅಂದ್ರೆ MCQ 2 ಬರುತ್ತೆ. ಓಕೆ, ಬ್ಲೂ ಪ್ರಿಂಟ್ ಪ್ರಕಾರ MCQ 2 1 mark question 1, ಓಕೆ 2 mark question 1, 3 marks questions. ಸೊ ಒಟ್ಟು ಇಷ್ಟು ಬರುತ್ತೆ ಅಷ್ಟೇ. ಸೊ 5 marks ಮತ್ತೆ ನ್ಯೂಮೆರಿಕಲ್ಸ್ ಇರಲ್ಲ. ಸೊ ಈಸಿ ಆಗಿ ಇದನ್ನ ಈಸಿಯಾಗಿ ಸ್ಕೋರ್ ಮಾಡಬಹುದು. ತುಂಬಾ ಡೆರಿವೇಶನ್ಸ್ ಎಲ್ಲ ಜಾಸ್ತಿ ಇರಲ್ಲ. ಸೊ ದಟ್ 1 mark ಕಾಸ್ಟ್ ಡೆಫಿನೇಷನ್ಸ್ ಎಲ್ಲ ಇರುತ್ತೆ ಈ ತರ ಎಲ್ಲ. ಸೊ ದಟ್ ವಿ ಕ್ಯಾನ್ ಕ್ಯಾರಿ ಔಟ್ ಈಸಿಲಿ. ಸೊ 2 marks in 1, 3 marks in 1 ಅಂತ ಬರುತ್ತೆ. ಒಟ್ಟು 8 marks ಇರುತ್ತೆ. ಇವತ್ತು ಇದಿಷ್ಟು ಸಹ ಈ ಸೆಷನ್ ಅಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಮಾಡಕ್ ನೋಡ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಯಾವ ತರ 1 mark ಕ್ವಶನ್ಸ್ ಇರುತ್ತೆ, MCQ ಇರುತ್ತೆ ಅಂತ ನೋಡ್ತಾ ಹೋಗೋಣ. ಸೊ MCQ ಗಿಂತ ಏನು ನಾನು ಹೇಳ್ದಂಗೆ ಎಲ್ಲ ಡೆಫಿನೇಷನ್ಸ್ ಗೊತ್ತಾದ MCQ ಸಹ ಸಾಲ್ವ್ ಮಾಡಬಹುದು. ಅವ್ರು ಹೇಗೆ ಕೇಳ್ತಾರೆ MCQ ನಲ್ಲಿ ಅಂದ್ರೆ, ಓಕೆ, ಲೆನ್ಸ್ ಲಾ, ಫ್ಯಾರಡೇಸ್ ಲಾ ಇದನ್ನೇ ಕೇಳ್ಕೊಂಡು ಹೋಗ್ತಾರೆ. ಸೊ ಅದ್ರಲ್ಲಿ ಏನಿರುತ್ತೆ ಅಂತಂದ್ರೆ ಆಪ್ಷನ್ಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಅಷ್ಟೇನೆ. ನೋಡಿ ಹೇಗೆ ಹೇಳ್ತೀನಿ ಹೇಗಿರುತ್ತೆ ಅಂತ. ಇಸ್ ಡಿಫೈನ್ಡ್ ಆಸ್ ಅಂತ ಕೊಟ್ಬಿಟ್ಟು ಸೊ 4 ಆಪ್ಷನ್ಸ್ ಕೊಡ್ತಾರೆ. ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಅಂದ್ರೆ ಏನು? Electromagnetic induction means whenever there is a magnetic field is there, then what happens? Electric field is induced. Okay, electric current is induced in that. Okay, that is known as a electromagnetic induction. Okay. Next Faraday's laws, Lenz's laws ಎಲ್ಲ ಇರುತ್ತೆ. ಸೊ ಒಂದಾಗ ನೋಡ್ತಾ ಹೋಗೋಣ. Current is induced. Electric current is induced. Okay, ಅಂದ್ರೆ ಏನು ಎಕ್ಸ್ಟ್ರಾ ಏನು ಕೊಡ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ induced. Okay, when induced in a conductor when conductor is what? When conductor is placed in varying magnetic field ಅಥವಾ changing magnetic field ಇದ್ದಾಗ magnetic field change ಆದ್ರೆ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? current, electric current produce ಆಗುತ್ತೆ. That is known as electromagnetic induction. Next question is define magnetic flux through a surface. Magnetic flux. Magnetic flux is number of field lines. Okay, magnetic field lines. ಇದೇನಂತಂದ್ರೆ ಡೆಫಿನಿಷನ್ಸ್ ಗೊತ್ತಿದೆ ನಿಮ್ಗೆ. 4 ಆಪ್ಷನ್ಸ್ ಅಲ್ಲಿ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬಹುದು. definition is number of magnetic field lines passing through a given surface. ಅಷ್ಟೇ definition is like this. Okay, ಆದ್ರೆ ಅದನ್ನ passing through a given surface. ಓಕೆ, ಇದು ಹೇಗೆ ಬರೀತಾರೆ? ಈ ತರ ಎಷ್ಟೆಷ್ಟು ನಂಬರ್ ಆಫ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಎಷ್ಟು ಬರ್ತದೆ ಅದನ್ನ ಹೇಳ್ತೀವಿ. ಸೊ ಇಟ್ ಇಸ್ ಗಿವನ್ ಬೈ ವಾಟ್? ಸಿಂಬಲ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಇಸ್ ಫೈ. ಓಕೆ, ಎಲೆಕ್ಟ್ರಿಕ್ ಫ್ಲಕ್ಸ್ ಹೆಂಗ್ ಬರೀತು ಹಂಗೇನೆ ಸಿಂಬಲ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಇಸ್ ಫೈ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಇಸ್ its unit is what? Its unit is Weber. It's defined as B. Okay, magnetic flux over unit area is called magnetic flux density. Magnetic flux over unit area is known as magnetic flux density, that is denoted by B. Next is integral multiple of. So electricity alligu magnetic flux gu anta vyathyasa illa. Almost electricity hege explain ಮಾಡ್ತೀವಿ ಹಾಗೇನೆ integral multiple of. Okay, so it is the integral multiple of magnetic field over a area of cross section, and it is equal to, so integral multiple ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? Phi is equal to B of A into cos theta. Okay na? So this is about the ಅಲ್ಲಿ ಸೈನ್ ಥೀಟಾ ಬರ್ತಿತ್ತು, ಯಾವ್ದ್ರಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಆದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಅಲ್ಲಿ ಈ ತರ ಬರುತ್ತೆ. ಎಲ್ಲದನ್ನು ಸಹ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬಿಟ್ಟಿದ್ದೀನಿ ನಾನು. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಗೆ ಡೆಫಿನಿಷನ್, ಅಂಡ್ ದೆನ್ ಐ ಗೇವ್ ದ A is the area of what? Area of the field lines. Okay, so ಎಷ್ಟು ಏರಿಯಾ ಇಂದ ಬರ್ತದೆ ಫೀಲ್ಡ್ ಲೈನ್ಸ್, ಅದು ಆಂಗಲ್ ಬಿಟ್ವೀನ್ ದ perpendicular vector to the area of the cross section of the magnetic field. Okay, dimension is what? Dimension is m into L square into t to the power of -1 into at the power. ಇಷ್ಟನ್ನು ಕೇಳ್ತಾರೆ, ಈ ತರನೇ ಕೇಳ್ತಾರೆ. ಸೊ ಕರೆಂಟ್ ಇದೆ ಇದರಲ್ಲಿ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಹೌ ಯು ಹ್ಯಾವ್ ಟು ಸಾಲ್ವ್. ನೆಕ್ಸ್ಟ್ direction of induced field. So direction of the induced field. Okay, ಈಗ ಏನಾಯ್ತು? ಸೊ ವೆನೆವರ್ ದರ್ ಇಸ್ ಒಂದು ಯಾವ್ದಾರ ಒಂದು ಕಂಡಕ್ಟರ್ ಇತ್ತಂತಂದ್ರೆ ಇದ್ರ ಮೂಲಕ ಏನಾದ್ರು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಪಾಸ್ ಆಯ್ತಂದ್ರೆ, ವೇರಿಯಿಂಗ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂದ್ರೆ ದರ್ ಇಸ್ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್. ಓಕೆ, ವಿ ಹ್ಯಾವ್ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್. ಬೇರೆ ಬೇರೆ ತರದ ಡೈರೆಕ್ಷನ್ಸ್ ಕೊಟ್ಬಿಟ್ಟು ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್ ಕೇಳ್ತಾರೆ. ಅಂದ್ರೆ ಇನ್ ಸೈಡ್ ಔಟ್ ಸೈಡ್ ಎಲ್ಲ ಇದ್ದಾಗ ಹೇಗೆ ಅಂತ ನೋಡೋಣ. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ನೋಡೋಣ. Direction of the electric field ಅಥವಾ electric field, induced electric field ಇದ್ರೆ induced current ತರನೇ ಇರುತ್ತೆ electric field. Induced current is given by what? Given by the Lenz's law. So how will get this one? Suppose if it is the suppose if this is the magnetic field lines. So ಇದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಇದ್ರೆ ಅದ್ರ ಸುತ್ತ ಏನಿರುತ್ತೆ? ಇಂಡ್ಯೂಸ್ಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರ್ತದೆ, ಇಂಡ್ಯೂಸ್ಡ್ ಕರೆಂಟ್ ಇರುತ್ತೆ. ಹೇಗಿತ್ತು? ಸೇಮ್ ಆಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಹೆಂಗಿರುತ್ತೆ ಹಾಗೆ ಉಲ್ಟಾ. ಸೊ ದಿಸ್ ಇಸ್ into B. Okay, if it is a magnetic field is in this direction, then the induced current, okay, induced EMF or the induced electric field is what? In a circulation. So like this, okay, circulates along the magnetic field. Okay, this is the induced electric field perpendicular to each other like this. Okay, so ಇವಾಗ ಏನು ಕೇಳ್ತಾರೆ? ಡೈರೆಕ್ಷನ್ಸ್ ಕೇಳ್ಬಿಟ್ಟು ಮಾಡ್ಲಿಕ್ಕೆ ಕೊಡ್ತಾರೆ. ನೀವೇನ್ ಮಾಡ್ಬೇಕು? ಸಪೋಸ್ ಇಫ್ ಇಟ್ ಇಸ್ ಅ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಈ ತರ ಇದ್ರೆ ಸ್ಕಿಮ್ಯಾಟಿಕ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಇಸ್ ವಾಟ್? ಸೊ ಇಟ್ ಇಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದ್ರೆ ಒಂದು ಕರೆಂಟ್ ಈ ತರ ಇರುತ್ತೆ. ಕರೆಂಟ್ ವಿಲ್ ಬಿ ಇಂಡ್ಯೂಸ್ಡ್ ಲೈಕ್ ದಿಸ್. ಇಟ್ಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಸೊ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತೆ these are perpendicular to each other. That we studied in the before that only. So what are eddy currents? One second. What state? Faraday's law, state Lenz's law of electromagnetic induction. ಇವಾಗ ಫ್ಯಾರಡೇಸ್ ಲಾಸ್ ಮತ್ತೆ ಲೆನ್ಸ್ ಲಾಸ್ ಎಲ್ಲದು ಬರೆಯುತ್ತಾ ಹೋಗೋಣ ನಾವು. Faraday's laws of electromagnetic induction. Next to Lenz's law of electromagnetic induction. Lenz's line the direction okay. So Faraday's law shows that, okay, Faraday's statement is what? Whenever ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೊಬೇಡಿ, ಲೆನ್ಸ್ ಲಾಗ್ ಇದ್ಕೊಂಡು ಸೊ MCQ ನಲ್ಲಿ ಇದ್ರೆ ಕೇಳೋದವರು 2 ಆಪ್ಷನ್ ಕೊಟ್ಬಿಟ್ಟು 4 ಆಪ್ಷನ್ ಕೊಟ್ಬಿಟ್ಟು ಇದನ್ನೇ ಕೇಳ್ತಾರೆ. whenever a conductor is placed in a varying magnetic field, what happens? An electromotive forces, an EMF is induced, and electromotive force is induced. Is induced, that is Faraday's laws. Induced current, so electromotive force is induced at induced current. If the conductor circuit is closed, current is induced. So the current is induced, you can say that whenever a conductor is placed in a varying magnetic field, electromotive force, the current is induced. Current electromotive force. So actually he written as EMF epsilon. Okay. That is the Faraday's law. Next comes the Lenz's law. The induced current is then the Lenz's law gives the directions. Okay, induced current is that opposes the next door. The Lenz's law states that direction of the electric field direction of current induced in a conductor by changing magnetic field current induced in a conductor opposes the change in magnetic field that created it. Induced EMF is always in the opposite direction, minus dz. So induced EMF is in the opposite about the change, opposes the changes opposes the change in the magnetic field. Okay, that is induced EMF is equal to minus d phi EMF. Idu EMF is equal to d phi by dt at the rate of change of flux linkage. Okay, EMF is equal to minus d phi by dt. This is the equation where electromotive force defies the magnetic flux to the conductor and rate of change of flux generates what? Rate of change of flux generates EMF. Okay, it is always in the opposite direction. That is the Lenz's law. Eddy currents. Now we have to calculate now about the eddy currents. Very, very important. So eddy currents. Induction cooktop iruttala. So induction cooktop also works on the principle of electromagnetic induction. So many AC, AC, everything AC generator, everything works on the principle of electromagnetic induction. Okay, so now we have to define about the eddy currents. Current produced. So eddy current is nothing but what? loop of current, loop of electric current that forms in a conductor when there is a change in magnetic field. When conductor is in what? Conductor under the influence of changing magnetic field. Very, very important. Here current form aguttho, EMF produce agatala. So that is known as eddy current. Loop of the current produced, okay, due to conductor is in changing magnetic field under that influence, okay. So eddy currents example, that is they will ask, okay. Free electrons iron irantado. So whenever magnetic flux in a transformer core in a magnetic flux change again. So in I2, so that is a free electrons in the iron move. Free electrons in the iron transformer core iron start agate move start agate eddy currents form agate. Eddy currents are formed due to the movement of the free electrons in the iron. Iron is what? Iron is a material. Okay, here it is. Applications of eddy currents where you can use it is an electromagnetic brakes. Induction stove work agate induction furnace. Induction stove works on what? Induction stove works on the eddy currents. Electromagnetic damping. Eddy current testing. So electromagnetic damping. Amplitude of the vibration of a metallic body in a magnetic field used to detect and characterize the surface and subsurface of the conductive materials. Eddy current comes from the circular path of currents, similar to the circular currents of water. It's called eddies. So eddy currents and eddies and circular flow irtalla eddy currents anta ಹೇಳ್ತಾರೆ. Okay, water loss eddies anta adanಗಾಗಿ ಇದನ್ನ circular eddy currents anta ಹೇಳ್ತಾರೆ. Next, self-inductance. Okay, SI unit self-inductance. Okay, define SI unit ಎಲ್ಲದೂ ಹೇಳ್ಬೇಕು ಇವಾಗ. ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಮತ್ತೆ ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಬಗ್ಗೆ ಬರೀತಾ ಹೋಗೋಣ ಇವಾಗ. ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಅಂದ್ರೆ ಏನು? ರೆಸಿಸ್ಟೆನ್ಸ್ ತರ ಇದು. ಇಂಡಕ್ಟೆನ್ಸ್ ಅಂದ್ರೆ ಈಚ್ ಅಂಡ್ ಎವರಿ ಮೆಟೀರಿಯಲ್ಸ್ ಹ್ಯಾಸ್ ಇಟ್ಸ್ ಓನ್ ಇಂಡಕ್ಟೆನ್ಸ್. ದಟ್ ಇಸ್ ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್. ಓಕೆ, ಮ್ಯೂಚುವಲ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಅಂದ್ರೆ ಏನು? ವೆನೆವರ್ ದೇರ್ ಇಸ್ ಓಕೆ, ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್ ಡಿಫೈನ್ ಮಾಡಿ ಮತ್ತೆ SI ಯೂನಿಟ್ ಅನ್ನ ಡಿಫೈನ್ ಮಾಡಬೇಕು. Same as the resistance only. Tendency of the coil. ಏನ್ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಇತ್ತೋ ಅದೇ ತರ ಇದ್ರೂ ಸಹ ಈ ಚಾಪ್ಟರ್ ಹಂಗೇನೆ ಬರುತ್ತೆ. Coil to resist changes in the circuit. Changes in the current flowing through it. Tendency of the coil to resist the changes. Okay, very important. Self inductance is the resistance. Okay, now ಅದು. Okay, electromotive. Next one is self inductance used in traffic lights and all. Inductance is Henry. Okay, SI unit is Henry denoted by L. Opposite to the changing current. Opposite to the changing current. Because of what? Just like the resistance. Okay, this is known as Henry. Next is mutual inductance. So if you want to define 1 Henry, SI unit of this one is 1 Henry. How to define it is the amount of self-inductance in a coil that produces an EMF. That produces an EMF of how much? 1 volt. When current, how much changes? When current changes at the rate of 1 ampere per second. This is Henry. Okay, ಇದನ್ನ ಕೇಳ್ತಾರೆ. ಸೊ ಎಲ್ಲದೂ ಏನಕ್ಕೆ ಕೇಳ್ತಾರೆ ಅಂತಂದ್ರೆ, ಸೊ ಜಸ್ಟ್ ಇನ್ನ 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಅಲ್ಲ, MCQ ನಲ್ಲೂ MCQ ಇದೆ, 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಇದೆ ಇದರಲ್ಲಿ. Both we have. Okay. Next comes mutual inductance. Self inductance ಆಯ್ತು, ಇವಾಗ mutual inductance. ಇರುತ್ತೆ ಕರೆಂಟ್. SI is basic resistance. Mutual inductance means it produces, okay, varying flow of electric current through one coil induces a voltage in the adjacent coil nearby. Mutual inductance describes how a varying flow of electric current through one coil induces voltage mutual, okay, in an adjacent coil. Okay, very important. This is the one we use in the transformers. Okay, next question is what is motional EMF? So everything, so many definitions are there. Motional EMF. An EMF that it is induced, whenever it moves, okay, that is induced in a conductor when it moves in a magnetic field. ಸುಮಾರು definitions ಕೇಳಿದ್ದಾರೆ. Okay, that is how to calculate this motional EMF. E is equal to, this is calculated using V into B into L. What is V here? V is the velocity. of conductor perpendicular to its length. L is what? Length. Length of the conductor. Velocity of conductor. Velocity of the particle moving. Okay. Velocity of the charge. Velocity of the electrons at the head. So charge. Okay. Velocity of the charge. The length is L. L is the length of the conductor and B is the magnetic field. The factors which affect, that is affect this one is nothing but what, which one is velocity. Factors which affect the motional EMF is velocity, magnetic field and length. Electric appliances, electricity. Okay, so this is how the motional EMF. Okay. On what principle AC generator works? AC generator works on the principle of electromagnetic induction. Okay, AC generator. Okay, so next class, next topic, AC generator works on the principle of electromagnetic induction. Law of electromagnetic, Faraday's laws of electromagnetic induction. That's also there. So if they ask what's on the principle, Faraday's laws anta barbidibekiದ್ರೆ. Okay, so one more question ಈ ತರ ಕೇಳ್ತಾರೆ. Next. Next question is 2 marks. 2 marks questions ಹೋಗೋಣ ಇವಾಗ. So it is to define magnetic flux through a surface. Give its mathematical formula in vector form. So ಈಗ ಏನು ಹೇಳಿದೆ magnetic flux ಅಂದ್ರೇನು? So mathematical formula of magnetic flux. Vector form ಕೇಳಿದ್ದಾರೆ. Number of field lines. Okay. Number of field lines. Vector form ಅಂತಂದ್ರೇನು? Phi of B is equal to BA cos theta. Okay. Or you can write phi of B is equal to B dot of A, dot product of this one. So area is A. There is a B is what? Magnetic field. Okay. This is a very big flux. It is a magnetic flux. Okay. Magnetic field lines. Okay. Flux is there. Magnetic flux is the field is there. Magnetic field is there. Next is what? BA. That is in terms of dot product. State and explain state and explain the Faraday's laws there. Wheel with 10 metallic spokes which of rotated revolutions for this one. So component of first magnetic field. What is the induced EMF between the axle and the rim of the wheel? So on the wheel ಇರುತ್ತೆ. State and explain lens law ಇದೆ. ಅದನ್ನ ಹೇಳಾಯ್ತು ನಾನು ಇವಾಗ ಒಂದು ಕ್ವಶನ್ ಕೇಳಿದಾರೆ ಇಲ್ಲಿ 2 marks ಅಲ್ಲಿ. Wheel with a wheel with 10 metallic spokes. 10 metallic spokes ಅದು ರೊಟೇಟ್ ಆದ್ರೆ ಸಾಕು. ಸೊ ವೀಲ್ ಕೆನ್ ಸ್ಪೋಕ್ಸ್ ಇರುತ್ತಲ್ಲ, ಈಚ್ 0.5 meter long, okay, is rotated with a speed of rotated with a speed of 120 revolutions per second. RPM, okay, 120 revolutions per minute, okay, RPM. Arts magnets, okay. So what is the induced EMF? Induced EMF, okay. Given induced EMF E is equal to d phi by dt. Okay, now this is the equation. Okay, induced EMF phi. E ಅಥವಾ epsilon ಅಂತ ಬರೀತೀವಿ ನಾವು. Actually ಹಿಂಗ್ ಬರೀತೀವಿ induced EMF ನ. Okay, that is equal to what? D into B of A divided by dt. So ಇದನ್ನ ಫಾರ್ಮುಲಾ ಅವಾಗಲೇ ಹೇಳಾಗಿದೆ. Correct or not? So this is the equation. Next is instead of B, okay, A is what? A is equal to d by dt of B into R square into d phi by dt by 2. Okay, R square is area. D phi by dt. That is equal to B into R square of omega. R square of omega is there. Omega is what? Revolutions per second. Adina circular rotation iradrinda omega barutte. So 120 revolutions per minute. That is 2 revolutions per second. That is omega is how much? Omega is 2 into pi into R. That is equal to 4 pi radians per second. Correct? So 4 pi radians per second. R is equal to how much? R is 2.25. 0.5. Okay, so if substitute here B is what? On the earth it is 0.4 gas. Okay, 0.4 into 10 to the power of minus 4 Tesla. ಎಲ್ಲದನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ ಇದು 2 marks 3 marks ಕೇಳ್ತಾರೆ. E epsilon is equal to half of B into R square into omega. That is equal to substitute ಮಾಡಿ half of B into B is how much? 0.4 into 10 to the power of minus 4 to 0.5 whole square into omega is 2 pi. 6.28 into 10 to the power of minus 5 ಇಷ್ಟು ಬರುತ್ತೆ. ಇಷ್ಟು ಮಾಡಬೇಕು. ಯಾಕಂದ್ರೆ 0.4 into 10 to the power of minus 4 is ಅಂದ ಅರ್ಥಕ್ಕೆ ಕೊಟ್ಟಿರ್ತಾರೆ. ಅದನ್ನ ಆನ್ಸರ್ ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿರ್ತಾರೆ. ಮಾಡೋಣ ಇದನ್ನ. ಈ ತರ ಸುಮಾರು ನ್ಯೂಮೆರಿಕಲ್ಸ್ ಇದೆ ಇದರಲ್ಲಿ. ಸೊ ನ್ಯೂಮೆರಿಕಲ್ಸ್ ಎಕ್ಸಾಕ್ಟ್ ನ್ಯೂಮೆರಿಕಲ್ಸ್ ಅಂತ ಇಲ್ಲಿಂದ 2 marks ಅಲ್ಲೇ ಕೊಟ್ಟಿರ್ತಾರೆ ಈ ತರದ್ದು. ನೆಕ್ಸ್ಟ್ mention 2 applications of eddy currents. Okay, so mention 2 methods of reducing it. The magnetic flux linked with the coil changes from this Weber to Weber in 1 second. So calculate the induced EMF in the coil. Induced EMF. Okay. So what is that? What they're asking is substitute ಮಾಡಿ ಬರಿದ್ರೆ ಆಯ್ತು ಅಷ್ಟೇ ಇದನ್ನ. So here it is. The magnetic flux linked with a coil changes from 1.2 into 10 to the power of minus 3 Weber to 6 into 10 to the power of minus 3. 6 into 10 to the power of minus 3 Weber in 0.1 second. In 0.01 second. In 0.01 second, calculate what? Calculate the induced EMF. So, induced EMF. So, how to solve this one? Difference sustainability. Okay. So, it is that is given by change in magnetic fields induced EMF. Change in magnetic flux is what? Change in magnetic flux delta of phi is equal to, okay, that got to calculate first, right? Induced EMF of it, okay. So change in magnetic flux is equal to 6 minus 6 final minus pi of final minus pi of initial. That is 6 into 10 to the power of minus 3 minus 1.2 into 10 to the power of minus 3. 10 to the power of minus 3 is what? Common. 6 minus 3 is 4.8 into 10 to the power of minus 3 Weber. What they're asking? They're asking for induced EMF. Induced EMF is equal to what? d phi by dt, correct? Not rate of change of this, the change with respect to time, correct? 4.8 into 10 to the power of minus 3 divided by 0.01. Okay, 4.8 into 10 to the power of minus 3 divided by 10 to the power of minus 2, 48. So 48. So that is a change in the magnetic flux. Okay. 0.48 over. Induced EMF. Number of turns ಕೊಟ್ಟಿದ್ರೆ ಅದನ್ನು ಸಾಲ್ವ್ ಮಾಡಬೇಕಿತ್ತು. ಇಲ್ಲಿ ಇಷ್ಟರಿಂದ it is induced EMF formula. In terms of volts, correct? No? So it is in terms of induced EMF. Volts. So that is induced EMF in terms of volts. So if this is equal to E at the ಬರೆಯುತ್ತೆ d phi by dt, that is volts ಅಂತ ಬರೆಯಬಹುದು. Easy. 48. So it is 4.8 into 10 to the power of minus 3. ಇಲ್ಲಿ ಏನಾಯ್ತು 10 to the power of plus 2 ಆಯ್ತು. Correct? Not. So it is 10 to the 4.8, 0.48 volt. Okay. 0.48. Next. These are the 3 marks questions. So deduce an expression for the self-inductance of the coil. Okay. Expression for self-inductance of the coil. Self-inductance of the coil is defined as the ratio of the total flux. Okay. It is defined as total flux enclosed. Okay. Phi by I to the current flowing in it. Okay. Number of turns. Okay. Ratio of total flux. Ratio of total flux with the coil to the current flowing through it. Okay. So that is when the current is varied, the flux linked with the coil changes. That is d pi by dt. Correct? Not L into di by dt. Okay, you can write that as equal to minus d into d phi by dt. That is if it changes. Okay. Minus L into di by dt. Okay, this is the self-inductance. The self-induced EMF is also called back EMF. Work needs to be done against now it has work needs to be done against work done is stored as magnetic potential energy. This work done is given by dW by dt is equal to epsilon into I, that is equal to L into I into di by dt. Okay, no need of the sign. Okay, next one is what? Total work done in establishing current from 0 to I is W is equal to, so total work is what? Integration of work into dW, that is equal to half into L into I whole square. This is dW by dt. Okay, that is equal to this is the self-inductance. Okay, work done in calculating this one is half into L into I square. Self-inductance is what? Self-inductance is L into define self-inductance, and we have to arrive at the magnetic field. Okay, magnetic energy. Magnetic energy, energy stored inside this one is magnetic energy stored. Magnetic energy stored. Okay, that is in the form of inductances. This is the equation. So you have to arrive at this equation. Okay. Next, again, we are going forward. Going for the 3 marks questions. Okay. 5 marks questions ಎಲ್ಲ ಬರಲಾಗಿದೆ. 3 marks questions ಮಾತ್ರ ಮಾಡಲಿಕ್ಕೆ ಇದು. Next is explain, arrive an expression for the EMF induced in a coil due to varying current in the same coil. Current in the same coil. Okay, so we have to write an expression for this one. Same coil ಏನಿದೆ ಅಂತ EMF. Okay, consider a coil of cross-section area. So we have to consider a coil of cross-section area as, okay, it is in a inside what and in a magnetic field. Okay, it is like this. And this magnetic field is here. It makes an angle theta with the magnetic field. Okay, so it's having like this. Then what happens? Okay, rotating with the angular speed omega. Okay, magnetic flux through the loop in the given position is given by magnetic flux. Phi is equal to B dot of S. ನಾನು ಅದನ್ನ ಅವಾಗಲೇ ಹೇಳಿದ್ದೀನಿ. ಸೊ B dot S ಇರುತ್ತೆ ಅಥವಾ ಏರಿಯಾನು ಇರುತ್ತೆ. ಗಿವನ್ ಏರಿಯಾ. ಸೊ ಏರಿಯಾ ಅಂತ ಬರೆಯೋದು ಅಥವಾ ಬಿ ಎ ಅಂತ ಬರೆಯೋದು. ಲಾಸ್ಟ್ ಟೈಮ್ ಬಿ ಎ ಅಂತ ಬರೆದಿದ್ದೀನಿ, ಹಂಗೆ ಬರೆಯೋಣ ಇನ್ನು. It is equal to BA cos theta. Correct? Not BA cos theta. Cos of pi by 2 minus theta because of what? Because of this 90 degree. Okay. Now it is sin theta. That is equal to BA sin theta. Cos theta is sin theta. Convert ಆಯ್ತು. Next is what? Phi is what? Phi is equal to induced EMF is given by induced EMF is given by induced EMF is given by we know that induced EMF is given by state of change of correct, not flux. That is equal to what? That is equal to D times of BS of sine of theta. Correct? By T. That consists of what? Changes to BA of sine. BA of sine theta. Okay. BA of omega of cos theta. Differentiation of this one is cos only, sine of theta plus omega t. Okay. Cos of omega of cos theta plus omega. So here derive open expression for uniform magnetic field. Okay, phi is equal to n. That is actually what is this? Phi is equal to minus n into d phi by dt. Okay, so now n is what? N is the number of turns. Okay, that is the expression. This is the expression. Induced EMF. Okay, next is expression for current in the same coil, varying current in the same coil. Expression for energy stored in an inductor. Obtain an expression for energy stored in an inductor. Okay. self inductance. So it is energy stored. So energy stored ittalla W is equal to half into Li square calculate ಮಾಡಾಗಿದೆ. ಈಗ ಇನ್ನೊಂದು ಮಾಡೋಣ. That is known as formula I have to arrive at. Motional electromotive force. Okay, now we have to arrive at the energy stored in the that is equal to half into. So this is we already calculated. Correct or not inductorly, L is equal to half into Li square. So this we are calculated. Now what we are doing is we are arriving at the motional EMF. Motional EMF. Arrive at motional EMF. Okay. So it is concept of a charged particle like this. Correct not so one conductor is there. In a magnetic field, one conductor is there. Okay, in that what happens? So that the particle is moving with velocity v. Okay, next it is in a magnetic field m. Now it is as a straight conductor moving in a uniform and a magnetic field. Conductor is moving. Conductor is moving in a magnetic field. Consider straight conductor moving in a uniform magnetic field with velocity v. V. Okay, where B is what? Uniform magnetic field B with velocity V. What is the conductor of length L? Okay. So now it is the rate of change of flux. Flux is given by V into L into X. What is X here? Small area of cross section. Okay. Rate of change of flux. Rate of change of flux. Y of B is given by minus d phi by dt, that is equal to minus d by dt of B into L into X. Rate of change of X is nothing but what? Distance. X is nothing but what? It is moving with the distance. It is changing with the distance X. Okay. This distance, if it is moving, means that is a distance X. X is the distance. Next is B into, it is EMF is equal to minus d by dt of, what is it? Opposite the very well. Okay, minus d by dt of B into L into X, B into L into X, L is a constant to B into L is constant, and d by dt of X is nothing but velocity, that is equal to minus B into L into V. Okay, this is the equation. This is the electromotive force. So this is a W is equal to Q into V into V into L. Okay, epsilon is equal to B into L into V. That is W work done ಮಾಡ್ಬೇಕಂತಂದ್ರೆ ಇನ್ನೇನ್ ಮಾಡಬೇಕು? B into L into V. This is the equation. Okay, W is equal to, that is because this is equal to W by Q. Okay. So these are all the equations. You have to we have to be very careful. So this is ನಾವು ಡಿರೈವ್ ಮಾಡ್ಬೇಕಾಗತ್ತೆ. Next is AC ಬಗ್ಗೆ ಕೊಟ್ಟಿರ್ತಾರೆ ರಿಮಾರ್ಕ್ಸ್ ಅಲ್ಲಿ. These are all the expected questions from 3 marks ಗೆ. ಓಕೆ, 2 marks ಗೂ ಅಷ್ಟೇ ಸಿಂಪಲ್ ಆಗಿರೋದು. ಸಿಂಪಲ್ ಆಗಿ ನೀವು ಈ ಕ್ವಶನ್ಸ್ ಇರುತ್ತಲ್ಲಿ 2 marks ಕ್ವಶನ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ರೆಷನ್ ಫಾರ್ ಸೆಲ್ಫ್ ಇಂಡಕ್ಟೆನ್ಸ್, neat label diagram of AC generator ಕೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ AC generator ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋಣ ಅದರಲ್ಲಿ. ಅಂತಂದ್ರೆ 2 ಮಾರ್ಕ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ, 3 ಮಾರ್ಕ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. AC generator. So how the AC works? Okay, AC generator works on the principle of AC generator works on the principle of electromagnetic induction. Works on the principle of electromagnetic induction. Diagram ಕೇಳಿದರೆ diagram ಹೇಗೆ ಬರೆಯೋಣ? So ಒಂದು ಇದೆ, strong magnetic field ಇದೆ. Inside that, what is there? Is a coil. There is a rectangular coil like this. Okay. ಎರಡು ಆರ್ಮಚರ್ಸ್ ಇರುತ್ತೆ. ಓಕೆ, ಕಾರ್ಬನ್ ಬ್ರಷಸ್ ಇರುತ್ತೆ ಇದಕ್ಕೆ. ಓಕೆ, ಇದು ಆಕ್ಸಲ್. ಓಕೆ, ದಿಸ್ ಇಸ್ ಅ ಕಾಯಿಲ್. Coil is there, rectangular coil is there, number of turns will be there, it depends upon the number of turns. Okay, next slip rings irutte. Next alternating EMF ಎಲ್ಲಿದೆ? ಇಲ್ಲೆರಡು ಕಡೆಯಿಂದನೂ ಸಹ ಏನು ಬಂತು? alternating EMF ಬಂತು. induced EMF will be in a form of what? alternating EMF. alternating ಆಗಿರುತ್ತೆ. So alternating current ಬಂದಿದೆ. EMF induced will be of alternating one. Okay, so how it works? It consists of ಇದು ಕಾರ್ಬನ್ ಬ್ರಷ್ ಇದೆ. ಓಕೆ, ಸೊ ಇದು ಆರ್ಮೇಚರ್ ಇಂದ ಹೋಗಿರುತ್ತೆ, ಆರ್ಮೇಚರ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಬೇಸಿಕ್ an AC generator consists of an AC generator consists of coil ABCD ಅಂತ ಬರೆಯೋಣ, ಅರ್ಥ ಮಾಡ್ಕೊಳಕ್ಕೆ. ರೊಟೇಟ್ ಆಗುತ್ತೆ ಇದು ಆಕ್ಚುಲಿ. ABCD ಒಂದ್ ಪೋರ್ಷನ್ ಒಂದ್ಸಲ ರೊಟೇಟ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದ್ಸಲ ಪೋರ್ಷನ್ ರೊಟೇಟ್ ಆಗುತ್ತೆ. ABCD ಮೌಂಟೆಡ್ on a rotor shaft. This rotor shaft ಇದೆ. Okay, mounted on a shaft. Kept under magnetic field. Coil rotated in the magnetic field due to this magnetic flux. Magnetic flux is produced. Correct? Not magnetic flux is produced. From Faraday's laws. Okay, it is given by EMF, induced EMF, magnetic flux is produced. They given by if flux is equal to minus n into d phi by dt. Magnetic flux ಏನಾಗುತ್ತೆ ಅವಾಗ? This in turn produces what? Induced EMF. It is minus d phi by dt. Okay. Then into b into a into d by dt of cos theta. So cos of omega t. Okay. Differentiation ಮಾಡಿದ್ರಾಯ್ತು. This is the equation. Phi is equal to phi naught of sin of omega t. ಅವಾಗ ಏನಾಯ್ತು? So the alternating EMF is there, no? This is in a form of cos sine function ಬಂತು. Okay, so the given that's alternating EMF, so this is produced in alternating EMF. ಒಂದ್ಸಲ ಈ ತರ rate of change ಅಂದ್ರೆ flux change ಆದಾಗನು ಸಹ, okay, the magnetic flux produces, okay, magnetic change in magnetic flux produces what? EMF. Change in magnetic flux is produces, change in magnetic flux produces an EMF. ಒಂದ್ಸಲ ABC ಒಂದ್ಸಲ rotate ಆದಾಗ one alternating EMF produce ಆಗುತ್ತೆ. AD ಒಂದ್ಸಲ ಆಕ್ಸಿಸ್ ಮೂಲಕ rotate ಆದಾಗ so ಒಂದ್ಸಲ EMF produce ಆಗುತ್ತೆ. It should be in a alternating EMF and this is the form of the AC. Okay, this is sine wave ತರ ಬರುತ್ತೆ ಯಾಕಂದ್ರೆ alternating ಇರೋದ್ರಿಂದ. This is how we discussed about the AC generator. Okay, so ಇನ್ನು next class ಅಲ್ಲಿ AC ಇದೆ, ಅದರಲ್ಲಿ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ ಅಂತೆ. ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ AC ಎಲ್ಲ ಹೇಗೆ ಪ್ರೊಡ್ಯೂಸ್ ಆಗುತ್ತೆ AC ಅಂತೆಲ್ಲ. ಸೊ ಇವತ್ತಿನ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ನಾವು ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ನೋಡಿದೀವಿ. ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಫುಲ್ ಚಾಪ್ಟರ್. ಇದ್ರಲ್ಲಿ ಏನ್ ಬರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ 1 ಮಾರ್ಕ್ ಕ್ವಶನ್, 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಟ್ವೈಸ್. ಓಕೆ, MCQ ಬರುತ್ತೆ, 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ ಬರುತ್ತೆ, ಡೆಫಿನೇಷನ್ಸ್ ಎಲ್ಲ ಬರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ 2 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ, ಮತ್ತೆ 3 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ. ಇಷ್ಟೇ. ಸೊ ಇಷ್ಟು ಬರುತ್ತೆ. ಸೊ ಇದಿಷ್ಟು ನೋಡ್ಕೊಳ್ಳಿ, ಈಸಿ ಆಗಿ ನೀವು ಮಾರ್ಕ್ಸ್ ನ ಸ್ಕೋರ್ ಮಾಡ್ಬೋದು. ನ್ಯೂಮೆರಿಕಲ್ಸ್ ಬರಲ್ಲ, ಬಟ್ 2 ಮಾರ್ಕ್ಸ್ ಇದ್ರಲ್ಲೇ ಅಥವಾ 3 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲೇ ಸಹ ಅವರು ನ್ಯೂಮೆರಿಕಲ್ಸ್ ನ ಕೇಳ್ಬೋದು. ನಾಟ್ 5 ಮಾರ್ಕ್ಸ್ 5 ಮಾರ್ಕ್ಸ್ ನ್ಯೂಮೆರಿಕಲ್ಸ್ ಬರಲ್ಲ, 5 ಮಾರ್ಕ್ಸ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಬರಲ್ಲ. AC ಜನರೇಟರ್ ಬಗ್ಗೆ ಒಂದಿರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಸೊ ಹೌ ದ ಇಂಡ್ಯೂಸ್ EMF ಬಗ್ಗೆ ಎಕ್ಸ್ಪ್ರೆಷನ್ಸ್ ಡಿರೈವ್ ಮಾಡಕ್ಕಿರುತ್ತೆ. ಎಲ್ಲದಕ್ಕೂ ಸಹ ಡೆಫಿನಿಷನ್ಸ್ ಇರುತ್ತೆ. ಓಕೆ, so these things we have to understand and we have to solve in the examination. So ಅಲ್ಲಿಗೇನಾಯ್ತು, ಸೊ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ಇಂಡಕ್ಷನ್ ಚಾಪ್ಟರ್ ಸಹ ಈಸಿ ಆಗಿ ಕವರ್ ಆಯ್ತು. ಸೊ ಇಷ್ಟೇ ಕ್ವಶನ್ಸ್ ಅಂದ್ರೆ ಇದೇ ಪಾಸಿಬಲ್ ಕ್ವಶನ್ಸ್ ಅಷ್ಟೇ ಬರ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ. 1 ಮಾರ್ಕಿಗೆ, 2 ಮಾರ್ಕಿಗೆ, 3 ಮಾರ್ಕಿಗೆ. ಸೊ ಇಷ್ಟು ನೀವು ನೋಡ್ಕೊಳ್ಳಿ, ಆರಾಮಾಗಿ ನೀವು ಮಾರ್ಕ್ಸ್ ನ ಸ್ಕೋರ್ ಮಾಡ್ಬೋದು. ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಬೇರೆ ಚಾಪ್ಟರ್ ಜೊತೆ ಬರ್ತೀನಿ, AC ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ಜೊತೆ ಬರ್ತೀನಿ. ಅದು ಅಷ್ಟೇನೆ. ಸೊ 1 ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಮುಗಿಸ್ಬಿಡ್ಬೋದು ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್ ಕ್ವಶನ್ಸ್ ಎಲ್ಲದನ್ನು ಸಹ. ನಮಸ್ತೆ.